Good morning. My name is Victor Moreno. I'm a technical lead in the data center business unit. I've met some of you before. Others, see some familiar faces. Good to see you guys. Others I haven't met, but I'm sure by the end of this conversation we'll probably know each other to an extent. So I'm going to basically dovetail into what Han was talking to you guys about, talk a little bit about where we see all of these different acronyms fitting in the network, how they may interact, what Cisco's direction is in terms of taking this into the future. And with that, depending on our time constraints, we'll probably go into some detail on LISP and mobility, which may be the one thing that you guys are less familiar with. So with that, I'm going to quickly try and level set in terms of some background definitions, which we probably are going to agree to disagree on, but I need this so that we can have a meaningful discussion in the next half hour or so. So when we talk about virtualization, obviously there's two strands to this theme, and one is that of partitioning, which has been basically the baby of a lot of the marketing that has been happening in the last roughly 3 or 4 years. And that leads to basically virtualized servers, and virtualized servers that are basically connecting to the network with hypervisor switches, basically software switches. There is also, and heavily used in production, basically the concept of clustering, or actually grouping together different identities under the umbrella of a single virtual entity. And that usually is done on bare metal servers. And these are bare metal servers that actually connect onto the network through physical devices. Right? So we don't have our insertion point from a networking perspective is not that hypervisor switch, it's not that software switch at that point. So what we end up with is a mix of virtualized networking and physical networking that we need to reconcile and basically bring together. Right? And there were some tidbits out there in the previous conversation on how we actually start talking about VXLANs, and do we map that onto VLANs or other constructs in the physical network, and do we use a gateway to actually achieve this functionality. How does this whole thing look is what we're going to be talking about, not just today, but moving forward as this whole conversation evolves. Right? You'll hear a lot about, there's tons of startups, there's tons of conversation about SDNs and what have you, and a lot of the networking that supports those SDNs is basically largely and heavily on this camp. And the trick is going to be, how do we actually integrate both worlds, because physical services are not disappearing anytime soon. Not everything is becoming virtualized, at least not immediately. And while we cross that chasm, we're going to have a few years where we're going to have to sustain the combined environment. There's also a lot of hype around movement, right? And our customers tend to heavily confuse moving versus distributing a workload. And when we talk about movement, there's also been a lot of conversation around the dependency on a layer 2, pervasive layer 2 network that is extended everywhere so that I can complete a move. And one of the things that we see from a networking perspective is you don't really need to extend the LAN in all its glory to actually complete a move. And extending the LAN in all its glory implies extending unknown unicast flooding, broadcast ARPs, and CDP, VTP, LACP, all of those protocols, right? Do we really need that everywhere? And the answer is probably not. We just need to present those virtual machines with basically consistent persona in their default gateway. So as long as they see the same default gateway, they're comfortable enough with basically their IP stack is comfortable enough talking to that network.
Unless they talk within the same layer 2 subnet.
And if they talk within the same layer 2 subnet, they're probably not exchanging CDP or LACP or any of that. And if I can give them connectivity without having to flood unknown unicasts and without having to broadcast ARP requests across the board, then we're in business, right? We provided what some of the architects at MSN called layer 2 semantics. right? So in the early days of some of the proposals there, they talked about providing layer 2 semantics over a layer 3 network, right? So that's largely what we try and do in LISP host mobility. It's not the only proposal out there, and you'll find commonalities across all the different proposals. There was a comment that I overheard about, well, this has all been done before in MPLS, and the way MPLS does these things is basically it creates overlays. It creates a level of indirection between the PEs and whatever's connected to them. So the task at hand is largely to map the endpoints to the attached points that they have into the network. And resolve, basically you've got two problems. One is the mapping, the other one is how do you best resolve the connectivity between the attached points on the network, the topology, right? So we'll talk a little bit about that, and based on those commonalities, I'm going to share with you where we intend to take things moving forward. Then on the other hand, we have basically the ability to distribute workloads that may actually require layer 2, and to Ivan's comment, basically there are applications that are not IP based and are largely relying on layer 2 link local multicasting, and those are going to require some level of a layer 2 service for those protocols that they use. The classic example is Veritas clustering. Veritas clustering basically takes the tag of taking all the keep alives of any cluster that's running on top of it and actually putting them into an Ethernet header, which they argue that is more efficient in terms of taking it from A to B, let alone the fact that inside of that there's an IP header for the actual keep alives that the applications are creating. But anyway, they throw that at the network and we need to cater for it. So you see space for LAN extensions moving forward. And hopefully we can actually take all the different flavors of LAN extensions, all the different flavors of overlays, and pull them into a single protocol. And I must emphasize protocol. Right now, you heard about VXLAN. It's a protocol-less solution, right? And it's a protocol-less solution for two reasons. One is simplicity in trying to get to market with the people who are behind it, right? You're trying to trivialize the network problem. You can trivialize it to an extent because you're single connected to the network. You are basically a virtual machine and a hypervisor switch, and you have one hypervisor switch and one hypervisor switch only. Because you're virtual, you have ways of creating resiliency that you don't have in the physical infrastructure. Now, we talked about logical networking interfacing with physical networking. So if we were to do VXLAN in the network, right, and this is something that some of our competitors claim that yes, we're ready to go, we'll do it, it's all defined. If you were to do this in the network, if you were to do an overlay in the network, we know what doing an overlay in the network entails because we've done it before with something like VPLS, right? And when we tried to do VPLS in the network for the data center, what we ended up having to do was adding a bunch of protocols or scripts or whatever your favorite flavor of a VPLS deployment is. So you got BGP extensions that were proposed by Juniper at some point. You've got MLACP that was pushed by some people at Cisco. Then you've got some EM scripts that are less than desirable, but they're out there and they work.
Radius?
Sorry?
There was a radius?
There's radius-based stuff, right? So when you look at all the things that you stack up to actually resolve this problem, you're thinking, well, why didn't we just design a protocol to do this? And that's largely what OTV attempted to do, right? So OTV attempts to address that very specific problem and give you the ability to multi-home a layer 2 overlay in the network, right? So the moment we push VXLAN into the network, we're going to have some level of intelligence. We're going to have that level of intelligence not only for multi-homing, but we're also going to have it so that we can efficiently trim our multicast trees. Right now we're looking at a shared multicast tree for all your control learning. Basically, your flooding happens over a multicast tree, and you use the same multicast tree to actually do the flooding of your multicast traffic, right? And therein lies the problem. You would have to basically go more specific with your data traffic and start trimming things back. So we have a lot of knowledge on how to do that using protocols and signaling. So hint, hint, VXLAN is going to need some level of intelligence added to it if we are to reconcile physical and logical, and if we are to move it to the next stage. Okay.
Just one question. When you talk about thank you, it's answered.
Okay. So
you're so good.
Great. Thanks. So
and you get it.
The benefit of coincidence,
so
right?
Come on. No, I'm not surprised.
Yeah.
I'm not surprised. I'm excited. There's difference.
So we got basically also the other area is what do you do about your services and all the state that you have in the network, right? And when we look at the operations that people are carrying out, a large amount of the operations falls into what we call cold moves, right? People are doing SRM operations. They're planning when they move a workload from one place to another. Personally, if I was an IT person and somebody asked me, well, I have all my production traffic and I've got all my users connected to this machine, I want you to move it live. If this is an enterprise, I would probably argue there's probably not a reason for that. We could probably plan this and keep everybody happy and not have to run that risk. There are, however, service providers where they don't have any control on the subscribers that are connecting to those workloads, right? And in those cases, there is no agreeable time window where you're going to be able to do a maintenance and have 10,000 customers agree, yeah, this is a good weekend to do this, right? So in their case, live moves are something that does potentially come into play, right? They have other mechanisms to actually do their operations, but in any case,
like load balancers,
for example, right? So in any case, when you have these hot moves, they're much more challenging. You have to preserve state on your services, on your firewalls, on your load balancers, and we'll talk a little bit about what we can do in that area. But you're also going to be limited in distance. How far can you really take this? These machines are not just connecting to the front, they're actually connected to the back end, to a ton of data. And the question is, how can I effectively replicate that data between data centers, right? And if I can replicate it between data centers, well, how far can I go before this data is actually out of date, right? So the machine might be moving faster than the data, and that's basically your limiting factor. We've tested things all the way up to 400 kilometers, and that's likely to increase a little bit. Of course, all our storage partners keep working on this, but that's basically, those are the limitations. So there's always going to be something that limits things. It's either the storage or the application times out. vMotion, for example, as an application, times out at 5 milliseconds of return trip time. That's where the 400 kilometers came from. And you've got also things like services that you may be extending a cluster of firewalls. And if you're extending a cluster of firewalls, that in itself is an application that may have a timeout budget, right? So those are our two scenarios. So
I do have one question.
Yep.
Not necessarily about the specific thing that you were saying, but it's a pattern that keeps repeating itself. You mentioned, what was it, Veritas clusters and their layer 2 requirements. We all know about VMware's layer 2 requirements. Why is it that every single networking vendor in the world is trying to work around the broken applications?
Yep.
And why are not applications themselves being fixed with the help of the networking industry?
Really, Julie, you're really going to ask that?
Thank you. No, thank you.
Well,
I
it's,
was going to say, has that ever worked in the past?
history. Yeah, I was going to say history.
I've been doing this since
Right.
bats have roamed the earth. Right? And in those interim 30 years, the network and the infrastructure folks have been bitching about the application folks the entire time. And the application folks bitch about the infrastructure
Because
folks
it's
saying,
always
why
a
can't it do
network
what I
problem.
need it to do?
always
So
a network
it's a fine question, and with enough unicorn tears and fairy dust, we'll probably get it fixed. But in the interim, I think for most organizations, for most infrastructure folks, they get a burning bag of something that they have to deal with.
No, I understand that. I'm not very young myself.
Randy Bias is a top person on Twitter. He had an interesting article that basically said that cloud computing is starting to split into two camps. One camp which says you have to rewrite your apps to be distributed and fault tolerant so we don't have to think about this. And another camp that says, well, no, we can solve this and you can port your legacy apps to it. And it's sort of splitting in two directions. So it's like a parallel to what you're sort of asking.
So my experience is anything, any infrastructure strategy that depends on the apps folks doing something, it's going to fail.
So but you guys have addressed this already today. I mean, you talked about it in VXLAN, and we're all network guys here, so it's a relatively cohesive group. But from the perspective that you guys say you're working with these guys to solve these problems, that the software problems are wagging the network tail. We have the experience in this. We see the vision where it goes, and we have to lay an infrastructure to work on. So you guys have a big stick to wield in this game to say this is how you do it right. You have an investment in the people who are doing it wrong.
And also, to build on that, it's just the fact that we know it's wrong. We know all the problems. We have seen them all before. And as he said, I mean, you have a stick. I mean, the amount of effort, the amount of energy, the amount of money, the amount of man hours that are going into working around broken applications that don't, in many cases, they don't really require a lot of fixing, other than just telling them, look guys, you really don't need layer 2 keep alives. You really can do that over IP multicast? Seriously?
I mean, even Microsoft got that.
Even
Windows clustering.
Thank you, even Microsoft got
I
it.
don't think anyone is going to argue. Right, this is what you're saying.
So-
From a practical
Let's move
perspective,
forward.
But from a
But
practical perspective, if someone brings up an application and it falls on its butt because of some networking issue, it's a networking team or the infrastructure team that's going to get the blame, not the apps folks. Right. So I think from an infrastructure perspective, you're always working from somewhat of a defensive stance. Stuff rolls downhill, and usually infrastructure folks are sitting at the bottom of the hill. So you work from a defensive stance and say, you're going to try and build infrastructure, no matter what they throw at it, it's going to stay on its feet. Should it work that way? Absolutely not. But yeah. Okay. At some point you just get tired of getting thumped and say, okay,
so I think my version of the answer to that is we haven't given up, right? We continuously work with the leading vendors, right? So people like the Oracles of the world, the Microsofts of the world. We're continuously working with them. However, there's a ton of homebrewed stuff that is going to continue to come up, right? And yeah,
And Fortran.
I mean, right. And we're basically, from that perspective, we've kind of given in, if not given up, right? So that's where you see a lot of the layer 2 happen, right? And that's a good leading conversation into what we have here. So basically what we see in most customers is a couple of main data centers that are active and are expected to be both active and servicing traffic as the main locations. And then I tried to show something far away, which is basically our disaster recovery facility, or it could be a hybrid cloud facility. In any case, we're going to be basically looking at hot moves and active stretching of applications between these active data centers, and that may or may not require some layer 2 extension, but what will be required between any of the locations will be the ability to actually move the workloads, right? To reposition workloads while maintaining IP addresses. And as we reposition those workloads and maintain the IP addresses, we also need to have the concept of segmentation that Han was talking about, right? So this concept of 24 bits that gives us 16 million different segments cannot only exist in VXLAN. It needs to be extended to the physical infrastructure and to the protocols that we're using in the physical infrastructure. So when you look at a LISP header, when you look at an OTV header, when you look at a VXLAN header, you're going to see the same 24 bits in all of these headers, right? And you're going to see those 24 bits in all the signaling protocols that are associated both with OTV, LISP, and eventually whatever we use in VXLAN, right? So the question is, if we've already done it once, then why do it again? And the answer may very well be, well, we won't necessarily do it again, but we may actually leverage something like LISP, for example, to enable VXLAN functionality moving forward. Okay. Complementary to this, right, we may need some level of LAN extensions, right? And I will say that when you have an endpoint that has both an IP address and a MAC address, now you've got two names for the same place, or for the same entity, right? And if I can reach it via IP address for unicast purposes, there is very little point in also providing the MAC address information over a protocol. I already know how to get to this guy. Okay, so the LAN extension that we see here for things like clustering is probably going to be focused around handling link local multicast more than any unicast information. And if you look at those conversations, they are specifically link local multicast floods that go around, right? So we could take from what we have today, which is a complete LAN extension which does unicast, multicast, and everything else, we could take the lessons learned and could we integrate into our mobility mechanism basically just the ties to do link local multicasting across these sites. So kind of a half layer 2, just take what you need, right? Rather than having to learn a bunch of MAC addresses which are in a flat space that we can never aggregate, right? And if we don't have to learn the unicast MAC addresses, then we don't have to carry the problem around of we've got this flat address space that we can't aggregate, right? But we can focus on an IP address space, which could be v4 or v6, and basically abstract things from the topology in such a way that we can actually continue to summarize. No matter what kind of entropy I have in terms of moving virtual machines or workloads anywhere in the network. So what happens today is if I attach here, I can be summarized here, but if I move here, then I've disaggregated my subnet and I can't continue to summarize, right? So if I remove my control plane from the infrastructure and actually have it in a database that can be organized in a virtual manner, then by virtualizing that control plane, I can continue to summarize. Because I can make things independent of the location. And that's a lot of what LISP brings to the table there. We'll talk about that. Yeah.
These are all the right answers. How much of this is feature, how much of this is future?
So I would say of the stuff that we mentioned, other than the layer 2 extensions brought into something like LISP,
yeah,
we have the mobility and the aggregability today.
Oh, that was exactly what was interesting, the last part. So that is future.
You mean the
combination of LISP with LAN extensions, yeah.
Right, that's roadmap.
Yeah, okay.
We're working on
Thank
it,
you.
but yeah.
Perfect.
Okay. So if I took a cross section of the requirements across multiple data centers and also in the cloud space, right? We're going to see some requirement for layer 2 connectivity, and we talked a little bit about what that may be, right? We're going to see a heavy requirement for IP mobility, and across the board a requirement for segmentation, all of it at scale, right? And if I look within the data center versus across data centers, I'll see today different solutions, right? So today, within the data center, you've got things like fabric path that give you layer 2 connectivity inside the data center, right? And it has certain desirable attributes. Fabric path in itself basically operates on the premise of having endpoints mapped to switch IDs, right? The switch IDs being basically the addresses of the attached points in the network, basically the access switches, right? So I have a layering of a protocol that allows me to provide connectivity between switch IDs. That's basically my core topology protocol. And then I have a mapping system that allows me to map the endpoints to those different switch IDs. Okay. So I have locations, which are the switch IDs, and I have identities, which are the addresses of the endpoints, which are MAC addresses in the case of fabric path. If I go across the layer 3 boundary, I could use something like VXLAN or OTV. Either one is actually mapping my identity, my endpoints, the MAC addresses of my endpoints, to a location, which in the case of VXLAN is the IP address of the virtual switch. In the case of OTV would be the IP address of the actual switches. Okay, so I'm mapping again location to identity in each and every case. If I'm cutting across data centers, as Han was mentioning, we recommend using something like OTV or VPLS. The reasons are several, right? We have one argument is let's just run VXLAN over OTV because there is no multicast support in the middle. Reality is when you use something like OTV or advanced VPLS, what you're really doing is isolating a lot of the layer 2 protocols between one site and the other, right? And that's where the value is. If I was just to do VXLAN across the board, basically what I'll end up with is basically an open flood domain where all the different layer 2 protocols will actually go across. Yes. So what we do, right, what we need to do is have a hardware gateway that basically gets you from VXLAN onto OTV, go across, and get back on VXLAN, right? The way that works is basically what we were mentioning before. The segmentation that happens in OTV needs to match the segmentation that happens in VXLAN. And what that means is the 24 bits that we have in the VXLAN header actually map straight into the OTV header. When you look at the RFCs for all of these things, you will see that the actual headers are identical. And it's not a coincidence. Okay?
That's the question you asked.
So you are saying that actually it's probably road mapped, but you could go from VXLAN through OTV to VXLAN and preserve the VXLAN ID.
Yes.
So it would be one layer 2 subnet while inserting all the goodies of OTV at the same time.
Correct.
And essentially avoiding the mistake that most people might make, and it is extend the VXLAN across the data centers.
Yeah.
Right. So they just use OTV for that.
Oh.
It is actually
No,
pretty cool.
yeah. Because yeah.
Good. So the question you asked is whether the control plane is smart enough in VMware to be able to coordinate it. So the capabilities in the underlying technology, right?
Yeah.
What Victor just talked about. Your question was whether the control plane or the management app is smart enough to pull that off. And the answer
Oh,
is
you mean
probably
digital
not quite right.
director? No.
So in the initial phases, right?
To have VXLAN between 2 data centers with proper layer 2 interconnect, if we have to do that,
Right.
it's cool.
Right.
It's
And
not there
and
yet,
there's
right?
it's not there today. No, I'm giving you basically where we're headed, right? So you could foresee a scenario where you basically come from one control to another, right? And the identities of the segments, right, would match across the board. Now, 16 million identities may or may not be enough. So there are also things in progress where you can actually take the identities and map basically identities that are locally significant to identities that are globally significant. And that could be 128 bits, for example. Right. So now you've got universal identifiers that can map to local identifiers. That's all work in progress. But the only way you can do that is if you basically abstract this from the data plane and have a mapping database that allows you to actually do those mappings and remappings. Okay? So you could have segment 1 and segment 10 actually be part of the same universal segment, say 100, right? And it is that mapping database that is going to basically tell the endpoints here, you are now talking to segment 1 because you're talking locally, and if you're going to talk across a chasm, you're going to encapsulate with segment 10.
This sounds like round target rewrite.
You could look at it that way. Yeah.
And the whole VXLAN to OTV mapping sounds so much like GMPLS, but that's just me being biased.
So you, with VPLS, with
Well,
that,
it's more of a one-to-one, just straight through, right?
Okay.
It's not hierarchical.
Okay.
Sorry. Go ahead.
the VPLS would require that you be able to terminate a VXLAN on a PE device, and that is something you're working on.
Yes.
Fantastic.
Yes. And that's the gateway that Han was talking about, right? What the gateway is basically you terminate VXLAN on a piece of hardware, and that piece of hardware takes it from there into VPLS, into OTV, or into VLANs.
Oh, so you're not thinking about moving OTV functionality into VMware, you're thinking about moving VXLAN functionality into PE.
Correct.
Yes.
Yeah.
Ah.
Hardware encapsulated VXLAN. It's a natural extension. You wouldn't. You need to VXLAN on the server. But to break it away from where it's been encapsulated, you need to de-NAT it.
Right.
Because VXLAN
Right.
is NAT, right?
No,
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 Yeah.
but okay.
no. NAT changes information with knowledge.
Right, but not let's argue that here.
Okay, before we dig into that, we've got about 5 minutes.
No, there are so many interesting
Sorry.
things in that slide.
I know,
Please leave that
I
argument.
know, I was only joking. I didn't
Yeah,
mean to do
this is it. I think
Stateless NAT, if we were to go down that path. But anyway,
Nat-free zone, keep going.
okay, NAT-free zone. So today, right? Once you have all these things in place, you're going to have basically movement of IP addresses, and they need to be reached from the IP network. And I'm showing reachability from client to the servers, but it also applies to server-to-server traffic, of course. And basically what we use there is, instead of, think of how you would solve it day one if the only thing you had was a dynamic way of injecting host routes. You probably inject a bunch of host routes into your IP network, right? That's less than desirable. So instead of injecting the host routes into the IP network, we basically have the host state maintained in a database of path, right? And that's what LISP, in a nutshell, is doing for us there. Now, that is based also on location identity separation, right? So the location being the IP addresses of the routers that take you onto the core, and the identity being the IP addresses of the servers, right? Now, we've seen Fabric Path, VXLAN, OTV, they're all doing location identity separation. So there was a question, are you actually taking OTV into VXLAN? And the answer is, we are basically allowing the hardware to encap and decap all the different types of headers, right? But on a control protocol level, we're going to try and unify all of this into LISP, so that you use basically the control protocol to resolve your VXLAN reachability, to resolve your multi-homing, your multicast, to go across, stop at the edges, provide any sort of layer 2 connectivity you may or may not require, and so forth. So think of a unified control protocol for all of these.
So you could, in theory, on LISP ITR, already insert packets into VXLAN segment. In
theory, yes. Because there's nothing in LISP that attaches you or limits you to having IP in IP. You could have Mac in Mac.
Oh, that's
You
true.
could have Mac in IP.
Yeah,
You could
okay,
have IP
okay.
in Mac. V4 in V6, V6 in V4,
That's
right?
the complication of the Mac header, yeah.
So you could use any header there, right? But there are significant advantages to having a protocol, right? And once you look at this proliferation of ideas, you start thinking, well, should we unify it into a single protocol? Okay. Some of the things that we're looking at, or some examples on how this could work, is basically when you have distributed clusters, you will see something like Fabric Path in operation. This is for physical servers today. And if I want to extend the physical cluster, I'm going to basically use something like OTV. And this is carrying basically my keep alives that we talked about. Right? And I'm going to use LISP to actually reach the virtual IPs wherever they may become active. Right? So if I have a virtual IP that's active here, and there's a failure, it probably become active here, and that's equivalent to a move. The only thing that's relevant to that move is not those keep alives that are going over the extended layer 2, but it's actually the IP reachability, right? So I have basically a role for an IP mobility solution in this whole thing. And if I look at the way the cluster is structured, I have two interfaces, one north-facing, and that's where IP mobility becomes relevant. Not so much layer 2 extension, but IP mobility. And then I have the interfaces that are basically the keep alive interfaces. And those are totally separate VLANs. So when I do a LAN extension for clusters, I'm actually extending the LAN for the keep alives, not the front-end LAN. I could extend the front-end LAN and provide some level of mobility. It'd be suboptimal. I mean, traffic will go to the wrong place and then correct itself over the layer 2 extension. But what we propose is basically using the IP mobility solution there.
Is that LISP IP mobility, is that similar to Amazon's Elastic interface?
I'm not familiar with Amazon's Elastic Interface. I apologize. But, I mean, we can take it offline. If you tell me a little bit what they do, I can tell you yay or nay. Then there's some interesting stuff that we're also doing in Lisp that, that you'll find interesting. If I look at my load balancers, normally my load balancer is making decisions on basically pulling in load. Now, I can start adding more power onto my data center all the way to where I overflow onto the next data center. And that might require that the load balancer has some level of layer 2 connectivity between the sites, right? So that I can do that distribution. Now, what we can do, and we can do this today with names, right? What we can do is have that load balancer on the east side actually basically keep track of who's become active and that there's capacity on the right-hand side, and have a policy that tells you, well, I'm going to affect my DNS system so that now I'm going to send some of the traffic here. And that's largely what the global site selector does, right? But it's based on names. Now imagine a global site selector that can actually talk to the LISP system and integrate basically the east data center into the load balancing pool based on IP addresses, which is very useful because there are many applications that are IP-based, not name-based.
So you're tweaking the map plane.
I'm tweaking that?
The map plane is the mapping between physical and
I'm having the global site selector talk to the Lisp mapping database, right? And what will result of that is that Lisp is going to now have different weights for the same destination, and it's going to send some traffic to the west, some traffic to the east. And when I send the traffic to the east, I can basically service that traffic locally without having to go across a layer 2 extension, right? So those are some of the things that we have committed there in Lisp. So we have 5 minutes, and I think the services is always a hot button when it comes to this. So I'm going to basically use my 5 minutes for that, and hopefully this has been useful. But when we have live moves, we have a challenge. When we have cold moves, not so much. In the event of live moves, we have a couple of things that we can do. We can actually take the state of the firewalls or load balancers and try and move it along. Okay, and that's largely what we do with the virtual ASA or any virtual appliance out there for that matter. So you're basically going to take the entire thing and you're going to move it just like you move a virtual machine. So your firewall is now a virtual machine, and as you move your VMs,
the firewall.
yes,
You're not moving the state of that firewall that's attached to a certain virtual machine.
you're moving the firewall with the state.
Yeah, you're moving
The whole
firewall.
thing.
Yeah.
Yes.
You're moving
So-
the box.
That is awesome.
Right.
Yeah.
So that's one thing, and that's something that we do, right, with the virtual ASA. That's something that other vendors that provide virtual firewalls also do. You move the whole thing, you're moving the entire state of it, right? Some people have asked, can you just move the state that's relevant instead of moving that heavy piece of state? Can you, if you just moved one machine, can I just move basically the fix-ups for that?
What about a context?
Yeah. No, it's a virtual firewall that's attached to the machine.
Yeah, but on the virtual firewalls, do you support contexts?
No.
On the virtual ASA? I'm not sure.
Yeah.
So on
I would
the
think so.
virtual firewalls, right? Like on a virtual security gateway, there's no notion of different contexts, because what you do is actually you have a different virtual security gateway instance for each.
So I just create, instead of
It's
a context,
already-
I create
it's
It's already a
Yeah.
context.
Yeah.
Okay.
Yeah.
It's already.
It's already a
context.
context in
So,
itself.
Okay,
so it's
fair
not like a physical firewall, you
Right.
gotta carve it up with different contexts, and the
Right.
VSG, you just have to.
It has only one
VSGs.
context.
I just
Right.
create a new virtual. Okay.
Right, right.
Every it's a file.
So the conversation on moving the discrete state, it's open. The question out there is, how valuable is it? Am I really doing moves that are that granular to warrant that kind of granular operation? We're probably moving so much that by the time you're done doing all that, you're better off either moving all the state, or you're better off not moving anything at all.
And you do a code move.
Well, you can do a cold move, but here's how things work on hardware today, right? I have my established flows, and I move my machine around, and what's going to happen is the flows are now attracted to the new place. These guys are in the same cluster, so there is some knowledge about the existence of the state for that flow in this firewall. This cluster is supposed to be all active, but when you look under the covers, what's really happening is there's a MAC redirect that happens so that you go to the member of the cluster that had originally instantiated that flow. So you're basically redirecting the traffic for that existing flow going through here, and you're going to need LAN extensions to do that because it's a MAC redirect. Okay?
So you're doing this today
That is done today.
with which firewall?
Any firewall in the market that has active clustering,
Ah, so that's how they do it.
not just Cisco. Okay?
Okay.
Then any new flows
Yeah.
will actually be instantiated on the local guy, and they will come through directly, right? Eventually, old flows are completed. I always say they time out. If I say to time out, that's a problem, right? Eventually, they complete, and this whole tromboning goes away. So eventually, it fixes itself. Now, the question is, can I do this without having to ask for these LAN extensions and therefore move to different places? And that's where something like knowledge of LISP type redirection comes in handy in the firewalls. That's future stuff.
Yeah, because that active-active doesn't really work very well in
Right.
the marketplace.
Right.
In fact, it's horrible.
It's broken. It's broken.
No, I
To
mean,
put it mildly.
no, yeah, I mean, I've seen that nobody in their right mind, like if you ask security engineers, I have never met one that actually chooses to run an active-active cluster.
So this
Right.
is not a smart thing to do.
No.
An
Therefore,
active-active-
it is being done.
Well,
It's only
Yeah.
when you get
Right.
senior management sees an idle firewall sitting by, and they say, "But it's being unused,"
Yeah.
and you're like, "Go away."
But these are virtual, so they can't see
this,
them.
this is a,
You can do it.
you know, you say that, Josh, but
He makes a good point.
I would argue that that argument is no longer valid because they are software firewalls. They're no longer operating relative to a host subsystem. They're no longer have synchronized routing tables or whatever. All the challenges that went with synchronized chassis-based firewalls are kind of not happening here.
But in the old school way, I mean, one is still like, I know on the Nokia side, what you're basically running a cluster, and one's like a master and sort of arbitrates.
Yes.
You know, oh, you have to go over there.
Yes.
You need to eliminate that idea completely, which it sounds like if they understand LISP, then you don't have to deal with that problem anymore.
correct.
Right?
That, if there's
Yeah, am I getting
Derek?
that?
Yeah.
Yeah. Okay.
False. Firewalls are always a challenge.
Now,
Not the
in
firewalls, it's the people that manage them.
Let's take it outside first.
Find out how blood resilient this carpet is before the session.
so while we fix our firewalls, and in the last 20 seconds that we have left,
Oh, I see.
Um,
She's fixing fire.
cold moves are probably not the problem and the clean way of actually doing this whole thing.
Question: you do have a load balancer icon up there. So my understanding is the ACE doesn't understand LISP yet either.
Correct.
But is that the plan? The plan.
So
is
what we're working on is the ACE understanding LISP so that it can do basically what we talked about in the former slide, where we do the global site selection, as well as a lot of the state movement that we're talking about.
I'm gonna ask a totally crazy question here. So LISP and is that your standard? Or is that you have to excuse me, or is that an open standard that you're?
It's an open
moving towards?
standard.
Okay, so like, are you guys? Is it potentially that I could put in other vendor stuff into this mix?
But why would you want to?
I know, crazy talk.
That is a stupid question.
It would be fair
All
to
be
say,
Cisco.
it would be fair to say that LISP is Victor's idea, and that Cisco, he has championed the implementation of LISP within Cisco, and Cisco is leading the LISP standards push. That is, there are no other vendors with LISP at this point.
I hear you. Okay.
So we
Well,
have
LISP is
Open source
yes.
implementations that you can run on the hosts.
Yes. And there, but Lisp is probably our best hope.
So, I'm a little out of the loop on this. We keep talking about a shared table in which all these different applications are going to reach back to. Is that going to be hosted on like a 7K? Is that going to be an external appliance? Where is a shared database of Lisp?
So today it's implemented on 7Ks, ISRs, any ISR, ASR 1000s. By the end of the year, you should have an implementation on the ASR 9000s, and as well as the CRSs. So right now, it's basically a process within the operating systems. The one thing that we're working on is basically productizing a server that will basically be a network appliance where you can run this. And the closest analogy to this is basically a DNS mapping system. And we're working very tightly with VeriSign. And VeriSign has been one of the operators to submit RFCs to the working group. We're working very tightly with them to actually create a DNS-like infrastructure that is Lisp
DNS
mapping.
works so well.
So we're going to switch over presenters, so both Victor and Han will be around for a couple of minutes to answer more questions over the minutes. There'll be some churn over on this side.
Thank you.
All right, thanks.